Good day, everyone. This is our public presentation for our thesis study entitled of Predictive Feed Formulation for Freshwater Aquaculture using Gradient Boosting and Real Code Genetic Algorithm. My name is JC Clarisan with my partner Kate Charles Callow. Fish feed is one of the highest costs in aquaculture. This study developed a predictive feed formulation system using MILP, RCGA, and gradient boosting to generate cost-effective, nutritionally balanced feeds and accurately predict feed conversion ratio or FCR. This study addresses three problems. Existing feed formulation methods cannot easily adapt to changing ingredients prices, and MILP has limitation in finding the best possible solution. And there is no integrated system that combines optimization and machine learning for feed formulation. To solve that problem, we have four objectives. First is generate feasible feed formulation using mixed integer linear programming that satisfy nutritional and biological constraints. Second is optimize feed formulation using a real code genetic algorithm to further minimize cost while maintaining nutritional requirements. Second, a third is to train and test the gradient boosting model to predict feed conversion ratio based on ingredient composition and environmental variables. Last is to test the developed mobile application incapable of generating optimized feed formulation and predicting feed conversion ratio, and evaluate its performance in terms of functional suitability, performance efficiency, reliability, usability, and overall acceptability. And for our MILP constraint satisfaction result, this table shows that MILP successfully generated feed formulation that satisfied all nutritional and biological constraints. This formulation served as an initial solution before optimization. Next is our RCGA result. In this table, after MLP generated the initial formulation, RCGA further optimized the ingredients combination to reduce feed cost while maintaining all nutritional requirements, resulting in a more cost-effective formulation. So, for our gradient boosting evaluation,
So this slide presents the performance of gradient boosting model. The evaluation metrics indicate that the model accurately predicts feed conversion ratio based on feed ingredients and environmental factors. So this chart shows the actual versus predicted FCR values from our gradient boosting model. Each point on this chart represents one feed formulation. The horizontal axis show the actual FCR value, what the formulation actually produce. The vertical axis showed what our model predicted. If our model were perfect, every point would fall exactly on red diagonal line. As you can see, the point cluster very closely along the line with minimal scatter. This visual confirms the high R2 curve were discussed. You will also notice three distinct cluster points, one for each life stage. Fingerling being the most feed efficient cluster around FCR of 1.0.3 to 1.33. Juvenile falls in 1.225 to 1.65 range. An adult which requires most per unit growth of cluster in 1.64 to 1.691 range. The model correctly learned these patterns from each life stage, which is exactly what we designed it to do. So this chart this chart shows the learning curve of our gradient boosting model. A learning curve tells us whether the model is actual learning from data or just memorizing it. The blue line the, represents the model performance on the training data. The orange line represents the performance during post-validation, which is model being tested on data it has never seen before. What we want to see both lines are converging on as more data is added, and that is exactly what happened here. And as the training size increases, the model across performs improves steadily, eventually reaching the high R2 score we discussed. First, the model is learning real patterns from data, not memorizing or guessing. Second, the model generalizes well to new unseen feed formation. This critical because in real world use, the model will always encounter new ingredients combination it has not been seen before. So in this slide, beyond the technical performance, we also about how real user experience the application. We conducted a system evaluation using standard ISO software quality criteria covering functional sustainability, performance efficiency, readability, usability, and overall acceptability. The application received a total grand mean score of 4.24 out of 5.0, interpreted as strongly agree. This means our evaluators strongly agreed that the system is functional, useful, and meet their needs. Usability received the highest rating at 4.51, meaning users found the app very easy to navigate and understand even without technical knowledge. This is especially important because our target user are farmers and not students. Overall acceptability scored 4.33 and functional suitability scored 4.32. Both rated as strongly agreed. Performance efficiency scored 4.15 and reliable scored 0.08, both rated as agreed. Overall, this result confirms that the application is not just technically sound, it is also practical, user-friendly, and ready for real-world use. So next slide. To conclude, this study successfully developed a predictive feed formulation system that integrates three technologies: gradient boosting for FCR prediction, MILP for nutritional constraint detection, and RCGA for cost optimization, all delivered through mobile application designed for aquaculture farmers. The system achieved all its objectives. MILP successfully generate nutritional complaint feed formulation for OT tilapia life stage. RCGA optimized dose formulation to be cost competitive with commercial feed using locally available ingredients. The gradient boosting model achieved R2 score of 92.8% of 295.9%, demonstrating strong predictive accuracy for FCR across all life stage. And the mobile application received grand mean evaluation score of 4.24 out of 5, confirming it is functional, reliable, and accessible to user. We believe the system represents a meaningful step forward in supporting Filipino aquaculture farmers, giving them access to specific data-driven feed formation that was previously only available to large commercial operations. The Aqua the Aqua AI system is cost-effective, pressure grounded, and ready to help farmers feed their fish smarter. We're confident in the work we have done, and we welcome any questions. To, and thank you very much for your time and attention. That's all. Thank you.